Hello everyone. First of all, thank you for taking out time to watch this video. Today we will try to understand the runtime areas of Java, Java virtual machine. So first of all, just have a very high high level overview of Java virtual machine, what it contains. So it basically contains the class loader system where your .class files are loaded. Then there is a runtime memory area. So these are required when you are executing the program. Then you have the execution engine, which is the interpreter, just-in-time compiler, converts the bytecode into machine code. There is garbage collection, which is run on the heap area. And then there are native method interfaces and libraries. This is the high level description of Java virtual machine. Now we look into the runtime data areas of Java JVM. So it is divided into two parts, you could say. One which is available for all the threads, and one which is for the whole application. So first is the method area. Method area basically close stores all your related information like uh, class name, superclasses, modifiers, static fields. All these are part of your method area. And heap area, it is basically storing your objects. Whatever objects you create, those are stored in heap. Stack area is basically per thread. So whenever you call any method, right, there are method is calling another another method. All this is stored in the stack area. And what is PC register? PC register program counter register. Basically, the last command executed. So it is like a cursor to that. And then native method stack is for the native related code. So we'll just review it again. What is method area? Stores class related information. So fully qualified name, modifiers, interfaces, static variables. All these are in the method area. Now heap area has the object data and instance variables also. And heap area is divided into young generation and old generation. Young generation is again further divided into three areas: Eden, S0 and S1. In the other video, where I'll be covering about the garbage collection, we'll look into this in detail. For now, uh, just try to keep in mind that heap is divided into two areas: young generation and old generation. And young is again divided into Eden, S0 and S1. Then we have stack area. Again, it is for the stack method frames, local variables, and partial results. Like I told about the PC register, it is for storing the command, last command executed, or the cursor to the command executed. We'll understand with this with an example. Just revisiting again, memory area. This is for JVM and shared by every thread. And stack PC register network method area, it is one per thread. So just keep this in mind. Next thing is, we'll take this example and see. So here what this code is doing. This is a class example. There is one static variable, then there is instance variable. We have this constructor, and then there is method. So this method has one parameter value, and then there is local variable temp. Then we are even calling system out.println. We have public static void main. Two objects are created, and we are calling this method. Now in your heap area, we have two objects, E1 and E2. So this is what we can see here. Since each object will have its own copy of instance variable, which is ID. So in case of E1, ID is 101, and in case of E2 is 202. And you can also see the reference of these objects is available in the stack area, E1 and E2. Also, this is string arguments. When we say string array arguments, it is also in a list of objects. String is also an object in Java. That is why it is in heap area. That is why you see here. And also the reference of this argument is there in the stack frame, which is in the main method, because it is part of the main method. For display this stack frame, we have this value 5 because we passed value 5 from main, and temp has value 10. 5 into 2 is 10, and then there is one reference to ID, right? So there is this reference. It is referring to E1 because I am calling E1 dot display. So this is how the objects are stored in the runtime areas. And as far as the method area is concerned, class metadata like name modifiers, method info, main, disflow, init, etc. Static variable count. What is the value of count here? Is 2. So because we have initialized two objects, so count is incremented. That is why the count value is 2. So this is how you can understand where what things are stored. This will help you in the performance optimization and garbage collection concepts. Say suppose if you move this reference from here, these two become orphan objects and these become eligible for garbage collection. I mean, we will cover this garbage collection in detail, but for now, just understanding these runtime areas is very important. Thank you so much. Hopefully, this has helped you. Thank you. Have a good day.